Your bone is a dynamic structure. The reason being, your bone continuously goes through the process of breakdown and formation. The old part of the bone, or the part of the bone that has suffered some microfracture, gets broken down. And then the part of the bone that gets broken down gets replaced by new bone. This continuous process of breaking down of old bone and the replacement of old bone by the formation of new bone is what we call bone remodeling. So what did I say? Your bone, it's a dynamic structure. Within 10 years, an adult skeleton gets replaced once. It's a dynamic structure. The reason being it is continuously going through the process of resorption, that is breakdown, and formation. So the whole process of bone remodeling can be divided into two parts. The first part is breakdown of the bone, or bone breakdown, where the old bone gets broken down or resorbed, and this is brought about by osteoclast cells, which are the macrophages of your bone, so called osteoclastic activity. And the second part is the formation of new bone, which is brought about by osteoblast cells, so called osteoblastic activity. So during bone remodeling, there's your osteoclastic activity where the old bone gets resorbed or broken down. And then there's your osteoblastic activity where the formation of new bone cells take place and the deposition of new bone takes place. The question arises, what are the various steps that take place during bone remodeling? What are the various activities taking place first during osteoclastic activity and then following that during osteoblastic activity? So this is what happens. Okay, so here I have a bone that has gone through a microfracture. The red cell that you see on the bone is the osteoblast, and the green cells are your monocytes. The osteoblast cells, they detect old bone or microfracture present on your bone, and as soon as it detects an old bone or microfracture, it releases rank ligand, where rank stands for receptor activator of nuclear factor kappa beta. We'll just say rank throughout the video. So the osteoblast cell, it releases rank ligand. The rank ligand has a receptor of its own called rank receptor, which is present on the surface of this monocyte cell. So the rank ligand attaches to rank receptor. As a result, the monocyte cell gets activated, and these monocyte cells, they fuse to form a much larger macrophage of the bone. And the macrophage of the bone is your osteoclast. The osteoclast now begins its osteoclastic activity. So what happened? There was your osteoblast, which detected a microfracture old bone in your bone and then released rank ligand. The rank ligand attached itself to rank receptor present on the surface of monocyte, and the monocytes, they fuse to form the macrophage of the bone, which is your osteoclast, which now begins osteoclastic activity. During osteoclastic activity, your osteoclast releases number one, lysosomal enzyme such as collagenase to break down the organic part of the bone, that is collagen. And it also releases number two, hydrochloric acid, which dissolves the inorganic part of the bone, that is hydroxyapatite, into calcium ions and phosphate ions. So the calcium ions and the phosphate ions obtained by the dissolution or dissolving of hydroxyapatite gets deposited in the blood. Now, within the site of activity of the osteoclast, if the osteoclast finds a bone cell, which is an osteocyte, which is probably old or damaged as well, then the osteoclast cell engulfs the osteocyte and eats the osteocyte. Now, as the osteoclastic activity is going on, your osteoblast secretes second thing. First, it had secreted rank ligand, which initiated osteoclastic activity. Now, as the osteoclastic activity is going on, it secretes osteoproteaserine. And osteoproteaserine, it binds itself to rank ligand, and it prevents the attachment of rank ligand to rank receptor. As a result, no new formation of osteoclast take place. Whatever osteoclast is already present completes its osteoclastic activity, and once they complete their osteoclastic activity, they commit suicide by apoptosis. So here was the osteoclast cell. The osteoclast cell completed its osteoclastic activity by breaking down the bone as well as eating a bone cell. And finally, after its job is done, it kills itself or commits suicide by the process of apoptosis. In a physiological condition, that is in a normal bone, your osteoclastic activity is balanced by osteoblastic activity. That is, the process of breakdown of the bone is balanced by the process of formation of new bone. So at the site where lacuna was formed by your osteoclast, or at the site where osteoclastic activity took place, now the osteoblast cells start secreting new bone to fill up that gap or fill up that lacuna. So it starts secreting new bone, and this new bone contains your matrix of the bone, which is formed by the combination of calcium and phosphate leading to the formation of hydroxyapatite. So it starts secreting hydroxyapatite containing matrix, which is called your osteon seam. And if, I repeat, and if the osteoblast gets trapped inside the osteon seam, then it itself gets converted into a bone cell or osteocyte. And this is how the formation of osteocyte in bone takes place. So the osteoblast during osteoblastic activity is responsible for two things. Number one, the formation of the bone matrix, and number two, the formation of new bone cells. And this is how the osteoblastic activity balances the osteoclastic activity, leading to bone remodeling in a physiological condition or in a normal bone. Now, the whole process of bone remodeling is dependent on the level of calcium in your blood. If the level of calcium in your blood is low, then your bone goes through resorption or breakdown, and then the calcium is pulled from the bone and added into the blood to increase the blood calcium level. If the calcium level is too high in the blood, then from the blood the extra calcium is pulled and deposited in the bone. Let's see what exactly happens. So in the first condition, the calcium level is below normal. In that condition, the parathyroid gland they start secreting parathormone. The parathormone, it signals the osteoblast cells to increase the release of RANKL. Increase in release of RANKL increases osteoclastic activity, which in turn increases resorption, which in turn increases conversion of hydroxyapatite in the bone into calcium and phosphate. As a result, the calcium ions which is obtained from the resorption of the bone gets added into the bone. It gets added into the blood. And the blood calcium level rises to normal. Second condition, if the calcium level is too high, above normal in your blood, then the parafollicular cells of your thyroid gland secretes thyrocalcitonin. And thyrocalcitonin, it inhibits osteoclastic activity and stimulates osteoblastic activity. That is, it stimulates the formation of bone, and for the formation of bone you need calcium, so that calcium can bind with phosphate to form hydroxyapatite. So the calcium, where does it come? It comes by getting pulled from the bone. The extra calcium gets pulled from the bone and deposited into the blood. This is how parathyroid hormone and thyrocalcitonin, two hormones that regulate bone remodeling by regulating the level of calcium in the blood. There's third thing, and that is vitamin D, which is responsible for the absorption of calcium from the gut into the blood. Without vitamin D, calcium can't get absorbed into the blood. And that's it for bone remodeling. And it is very important because the whole concept is going to be utilized in the next video, and that is osteoporosis.